Hello students, today we will find the expression IT as well as transient curve for this given RL series circuit, where it is first connected to this 100 volt source at time t is equals to 0, and then it is switched to this 50 volt source at time t is equals to 1 milliseconds, and we have to find its expression for both the positions. So first we will start from this position 1 at time t is equals to 0. It is connected to this 100 volt source. So we will start our solution at time t is equals to 0 when switch is in position 1. Okay, so our circuit is having a voltage source 100 volt and R and L in series. So first we will find the initial condition for this circuit. So for initial condition we will consider the circuit at time t less than 0 or t less than 0. At time t less than 0, this switch is not connected and it is open. So this inductor is getting no energy from this source. So we can say at time t less than 0, IL0 minus is equals to IL0, that is equals to 0 ampere. So it is our initial condition. Now we will apply at write KVL at time t is equals to, or you can say at time t greater than 0. When switch is connected, then we have to write KVL to find the expression IT. So here 100 is equal to first is 0.2 di by dt, first drop across inductor, plus second across resistor, that is 50I. So this is our equation. Now we can write this equation in this form: di by dt plus 50 divided by 0.2I is equals to 100 divided by 0.2. We can simplify this, and this will come equal to 250, and this will become 500. So this is our equation, and since this is our differential equation, so we can compare this differential equation with a standard differential equation, that is di by dt plus pi is equals to q. This is a standard differential equation where p is equals to 250 and q is equals to 500. And the solution of this differential equation is IT is equals to e to the power minus pt integration e to the power plus pt into q dt plus k e to the power minus pt. This is the solution of this standard differential equation. Now we will substitute these values to get the solution of our differential equation. So here IT is equals to e to the power minus 250t integration e to the power plus 250t multiplied by 500 dt plus k e to the power minus 250t. Okay, this equation will be integrated, and this will give us e to the power 250 divided by 250. Okay, because integration of this e to the power a is e to the power a divided by this a. So this is cancelled and this will become 1. So 250 by, will divide this 500, 2, and this integration sign you can remove from here. So this is equal to 2. So 2 plus k e to the power minus 250t is our solution or our transient current when our switch is at position 1. Okay, now we can find the value of k by using this initial condition. What is our initial condition? This IL 0 is 0 ampere. Okay, so put this current at t is equals to 0. Put t is equals to 0. So at I0, at t is equals to 0, I0 is nothing but 0 ampere. Using the differential equation is equals to 2 plus k e to the power 0 is nothing but 1. So k is equals to, here k comes equal to minus 2. Okay. So we got our differential equation. We got our differential equation, that is our transient current. So k is equals to minus 2. This is our transient current when switch is in position 1. Now we have to draw this transient current in form of curve. So our curve will be like this. It will be, suppose this is the position, this is nothing but this voltage V divided by R. This 2 is nothing but voltage divided by R. Okay, it is equals to, so our equation here, and this is time domain, this is t is equals to 0. So this is the curve for a circuit when it is in position 1. So here we got both the expression as well as transient current curve for this circuit when switch is in position 1 at time t is equals to 0. So this is our expression, and in a standard form we can write this expression as like this, because this 2 is nothing but V divided by R, this 2 is V by R, and this is minus R by L, and this is the curve which reaches its steady state at t is equals to infinite, and this is the maximum value, that is V by R. So this is transient current IT. Now we will find the expression and curve for the circuit when switch is in position 2. So when switch is in position 2, then 50 volt is connected in series with RL and given in the circuit. So first we will find initial condition, and this all happens at time t is equals to 1 millisecond. So initial conditions at t less than 1 millisecond. So at t less than 1 millisecond, the switch is connected to this position with voltage source 100 volts. So here current IL 1 milliseconds minus, that is equals to IL 1 millisecond, and it is nothing but 100 divided by this 50 ohm, because it is connected to this point, this position since long time, and before connecting to this point it is connected here, and this will behave as a short circuit. So 100 divided by resistance will give the value of current through inductor. That is our initial condition. So 2 amperes is the value of IL 1 millisecond. Now we will write KVL. Write KVL at t greater than 1 millisecond to find the expression IT. So here circuit is connected now to 50 volt source at t greater than 1 millisecond. So 50 is equals to 0.2 di by dt plus 50I. Now we can write this like this: di by dt plus 50 divided by 0.2 I plus is equals to 50 divided by 0.2. This will become 250 and this is also 250. Okay. This is again in the standard format of differential equation. Di by dt plus pi is equals to q. Okay, here p is equals to 250 and q is also equal to 250, and we know the solution of this differential equation, that is it is equals to e to the power minus pt. So here p is 250, t integration e to the power plus pt, that is 250t, multiplied by this q, that is 250 dt plus k e to the power minus 250t. Okay, this is the solution of the differential equation, and we written the value of our given equation, 250 in place of p and 250 in place of q also. So here integration of this will give us the value e to the power 250 divided by 250. Okay, its integration gives this value. This is cancelled, this is also cancelled and will become 1. So it is nothing but equal to 1 plus k e to the power minus 250t. Now to find the value of this constant, we will use initial condition. What is our initial condition? It is 2 ampere at time t is equals to 1 millisecond. So I 1 milliseconds is equals to 1 plus k e to the power minus 250 into again 1 milliseconds. Okay, what is I 1 milliseconds? The current flowing at time 1 milliseconds is 2 ampere. So replace this 2 is equals to 1 plus k, and e to the power minus 250 divided by 1000 gives 0.25 minus 0.25, and this e to the power minus 2.25 is nothing but 0.77. So this gives us the value of k. So here the value of k is 2 minus 1 divided by 0.77, and that is equals to 1.28. Okay, now we got the equation it when switch is in position 2. So it is equals to what? That is it is equal to 1 plus k. K is 1.28. K is 1.28 e to the power 1.28 e to the power minus 250t. Okay, substitute the value of k here and we will get the transient current at time t is equals to 1 millisecond. So this is our it. Now we will draw the curve for this it. So this is transient current when switch is in position 2, that is it is connected to this 50 volts, and we will draw the transient curve for this as this is transient curve. This is t is equals to 1 milliseconds. Here we have to take two values of this IT. One is 2 amperes and another is 1 ampere. Okay, so our curve gives value 2 amperes at 1 milliseconds, and this 1 ampere current would be flowing when I is infinity, or you can say at steady state, 1 ampere. Put t is equals to infinity here. So our curve will be like this. This is our transient response for when switch is in position 2. For position 2, or you can say for time t is equals to greater than or equal to 1 milliseconds. And this is curve when t is less than 1 milliseconds. So curve in combined form may be drawn like this.